I hope my screen is also visible to all of you.
Yes, sir,
So,
yes.
okay, great. So in the last session, we have started with the unit number 6, that is remote sensing and the computer modeling in hydrology. To start with this, we have discussed about the contents of this particular unit number 6. It will be going to start with the introduction to remote sensing. After that, we are supposed to discuss about the various principles that are involved in the remote sensing, which principles are going to be useful for the purpose of capturing the data which is present on the earth surface, and for that purpose we need to understand how this remote sensing actually works. So we are going to see these principles of remote sensing. In the last session we just discussed about, or we have listed about these principles. In today's session we will discuss something more about these principles of remote sensing. Then we will be going to discuss about the integration of remote sensing with the GIS, then remote sensing of the hydrological elements, various hydrological elements like rainfall, evaporation, transpiration, or in some climatological parameters, how we can able to identify that we will be going to discuss. Remote sensing applications in the terms of hydrological aspects, how we can make the use of this remote sensing technology, that will be going to discuss in this particular today's session. The point number 5 and 6, for that we are going to have few more sessions. Maybe tomorrow or day after tomorrow we are going to conduct some sessions related to these 2 points, that is introduction to the computer models for the hydrological part, and development of rainfall runoff model or the flood flow model using the remote sensing data, how we can make the use of this data for the purpose of developing the rainfall runoff model, that we are going to discuss. So we have defined the term called as a remote sensing, that is to capture the information for some of the objects which are present on the earth surface without any physical contact with that particular object. So remotely we are going to capture the data, and that data is going to be stored in the form of images. So this particular data we can use for the various purposes. Here we are just going to see the applications of this remotely sensed data as a part of images for the purpose of water resources engineering applications. Now talking about the next part, here we are supposed to discuss about the principles of remote sensing. So detection and discrimination of the objects or the surface features, that means to detecting or the recording of the radiant energy which is reflected or the emitted by the objects which are present on the surface or the earth surface, or maybe we can say the ground material which is going to be present. So different objects returns the different amount of energy in different bands of electromagnetic spectrum. In the last session we have also discussed about little bit in the terms of electromagnetic waves or electromagnetic spectrum. Electromagnetic waves, these are a combination of electrical and magnetic waves which are going to be helpful in the terms of, or we can consider it as a part of source of energy which is going to be required for the purpose of collecting the information in the remote sensing part. So in a view of that, these particular remote sensing principles, when we are going to see these electromagnetic waves, when these are going to fall on the any particular object or the earth surface, depending on their properties, like you can say the structural properties, chemical properties, or the physical properties, or make we will going to consider about the surface roughnesses, the angle of incidences, intensities. This particular energy, it will be going to get emitted or reflected back. This energy is going to be is captured, or it will be collected by the sensors which are placed, or we can say which are connected to the satellites which are placed into the space. So these particular sensors, when they are going to collect these electromagnetic waves back, they are going to provide that particular information to the receiver which are present on the earth surface. These are going to be considered as an process of transmitting these particular waves to the receiving sensors. So transmission, reception, and is going to be carried out And when this particular data is received to the earth surface, there is a very important step which is called as an image processing. So image processing is going to be carried out, and after carrying out the process on that image, we can make the use of that particular image for the purpose of interpretation or the analysis in the various parts, and we can have the application of these particular images in the various domains. So as we have already discussed in the last session also, like various principles which are going to be involved. First principle is the energy or the energy source, or we can say the illumination. So energy, the very first requirement for the remote sensing is to have the energy source which illuminates or provides the electromagnetic energy to the targets of interest. That is nothing but the information which is available on the earth surface that we should collect back, and that is nothing but depending on the completely energy source or the illumination. Then we are having the radiation and the atmosphere. These are the two important things that we need to take into account. This is the second principle. As the energy is going to travel its sources to the target, it will be going to come in contact with the uh, electromagnetic waves, or it may be going to interact with the atmosphere through which these electromagnetic waves are going to pass. And this particular interaction that may take place as a secondary part, or we can say that as a second time, and the energy which is traveling from the target to the sensor part. So there is a two-way, we can say the communication or the two-way transfer of this electromagnetic waves. These are going to take place. One is from the sun, so sun as a source, and another one is the satellite as a source. So from that, these radiations which are going to interact with the atmosphere, then we'll be going to have the interaction with the targets. Once this particular energy, it is going to travel, or it is going to make its own way to reach to the targets. After interacting with the atmosphere, it will be going to reach to the any particular object which is present on the earth surface, and depending on the property of that particular object, the radiation is going to get emitted or reflected back. So this particular process is nothing but the interaction with the target. So first the source, second one is the interaction with the atmosphere or the radiation, and the third one is the interaction with the targets. Next principle is recording of the energy by the sensors. So as I discussed in the previous slide about this particular reflected energy or the emitted energy from the objects, this energy is supposed to be captured by the sensors which are attached to the satellites. So when this energy is going to be scattered or it is emitted by the targets, we are supposed to require sensors which are placed remotely. Remote is not in contact with the targets actually. So that will be going to used in the terms of collecting or recording these electromagnetic radiations. Now, when sensor is going to record this particular electromagnetic radiations, next step is to transmit that particular data or this information to the receptors. That is process. That is the next process, or the fifth principle we can say, like a transmission, reception, and the processing. So the energy which is recorded by the sensors, it has to be transmitted, and this is often in the electronic form. This particular data or this energy, it is transferred to the receptors which are located on the earth surface. These are going to receive, and after receiving this particular data, the next step is to carry out the process on that received information or the data. That process is nothing but called as the image processing. So this data which is available in the form of electronic information, that will be converted in the form of electronic digital images. So you might have heard about some satellite images, various sensors which are that are going to capture the data of the satellite images, and depending on that, the name of that satellite image is given. After this presentation, I'll be going to brief you about the various types of data and what are the sources from which we can get the data at free of cost. So this particular data is going to be processed in the form of images as a part of digital image, that is going to be also called as a satellite image or the digital elevation models, etc. Now, when this particular data is ready, this data is supposed to be considered for the purpose of various calculations or the interpretation of information. So interpretation and the analysis, this is the sixth principle of the remote sensing. So the processed image, after collecting this information in electronic format, this particular information that we need to consider for the purpose of interpretation. So visually or digitally, we can interact with that particular image, and we can collect or we can extract the information about that particular targets which are eliminated by the electromagnetic waves and which are captured by the sensors. So interpretation of the digital image, that will be considered as the sixth principle of the remote sensing. Then after this information has been collected back or information is gathered, the next thing is that we need to think about the applications. So the final element or the final principle of the remote sensing process is going to be achieved when we are going to apply this collected information or the gathered information for the various studies or the various applications. So we have to use this particular data, or we are able to extract this information, and this particular data that will be used for the various applications, like in the terms of water resources engineering, if you will say, we can have the study of the land use, land cover data, or maybe in the terms of topographical studies, maybe in the terms of developing the contours, surveying, or maybe in the terms of designing some hydrological structures. We can get this particular data and we can make the use of this in the terms of solving the some particular problems which are related to the ground surface. And this is the very important thing, or we can say this is this these principles are going to be considered as a very important part. So these seven elements or the seven principles which are comprising the remote sensing process from beginning to end. So these principles you need to understand very this is considered as a very important thing, and you need to understand it very clearly. If some of the principle is not clear, then in that case the carrying out the process about the remote sensing will not be of any use. So first, as we have already discussed about the first principle, that is going to talk about the source of energy or the illumination. So we know that the source is nothing but it is in the form of electromagnetic radiation. So it is, in short, it is called as the EMR, electromagnetic radiation. So you might have studied about this electromagnetic radiation in your uh, 12th standard, that is during the physics course, that is electromagnetic radiation, or in your school days also you might have studied about a little bit about the electromagnetic radiation, which is, we can say, the basis for the formation of electromagnetic spectrum. So experiments with the electricity and the magnetism, it was carried out in the year of around 1800, which was developed a body of knowledge that led to James Clerk Maxwell to predict uh, around 1886 on purely theoretical grounds that might be possible for the electric and the magnetic fields to combine, and this particular waves, which is of combination of electrical energy and the magnetic fields, this is going to be considered as a combination. In combination to that, we it will be considered as an Maxwell's wave. So this particular Maxwell's wave, these are going to be of having a purely theoretical we can say the support, but not a practical support. Then in the year of around 1888, the Heinrich Hertz, he built an apparatus to send and to receive these Maxwell's wave. And in this case, the waves, these were around 5 meter long, and apparatus which is developed by the Heinrich Hertz, this was working very fine. And this particular study, when it is carried out by the Heinrich Hertz based on the Maxwell's wave, which was a theoretical, purely theoretical discussion about the electromagnetic waves. When this experiment was considered as a successful one, after that we are able to get, or we have learned that there are various lights or the various waves that are going to be a part of your electromagnetic waves. These are nothing but the X-rays, infrared or ultraviolet rays, or the radio waves or the microwaves, gamma rays. These all are nothing but the components of the electromagnetic waves. So how we can able to differentiate these various types of waves? So that is nothing but completely depending on the property of their wavelength. So there are various ranges of the wavelengths. These are going to divide, or these are going to differentiate these various types of electromagnetic waves. So the names of these particular divisions, these are going to arise from the interaction properties of each wavelength, that their range which is going to exhibit. So this electromagnetic radiation, EMR, this is a dynamic form of the energy that propagates as a wave motion at the velocity of c is equal to 3 into 10 raised to 8 meter per second. And the parameters that characterize the wave motion, these are going to be considered as wavelength denoted by lambda, frequency f, and the velocity c. That is nothing but your electromagnetic radiation. So electromagnetic radiation is, it is the dynamic form of energy that propagates as a wave motion at a velocity of c is equal to 3 into 10 raised to 8 meter per second. Okay, so this is considered as a electromagnetic radiation. So in the last slide we have discussed about this first requirement of the remote sensing is to have the energy source to illuminate the target, and this particular energy in the form of electromagnetic radiation is going to be considered as an source, or that energy source for the illumination of the targets. So electromagnetic radiation, all of you are aware of this electromagnetic radiation, that electromagnetic radiation, these are going to be consisting of the electrical field which is denoted by the capital letter E, which will be going to vary with the magnitude in the direction perpendicular to the direction in which the radiations are going to travel. That is nothing but the radiations of the magnetic field, which are denoted by capital M. So here you can able to see in this particular diagram this electrical field. This is the electrical field and this is the magnetic field. These are exactly perpendicular to each other. The magnitude is going to remain same, but their direction is exactly perpendicular to each other. So both the fields, these are going to travel with the speed of light, that is denoted by the letter C. So this is the electromagnetic radiation. So electromagnetic radiations, these electromagnetic radiations, if you are going to consider the study about this, so there are two important characteristics. These are going to be considered as a very important thing for the purpose of understanding the remote sensing technology. So first thing is nothing but the called as a wavelength, and the second thing is nothing but considered as an frequency. So what is wavelength and what is frequency? So from your school days you have started the study about this wavelength and the frequency. So wavelength, which is denoted by the letter lambda, so it is nothing but the length of one wave cycle, which can be measured as the distance between the two successive wave crests or two successive wave troughs, right? So wavelength which you are going to measure, that will be measured in the terms of meters or some factors of the meters such as nanometers, micrometers or centimeters. So this is what the we can say the distance which will be between the two successive crests, and this is going to be denoted by the letter lambda, that is nothing but your wavelength. Talking about the frequency, so frequency refers to what? Frequency refers to the number of cycles of wave passing at a fixed point per unit time. So whatever the time limit you are going to consider, say for the 1 per second or per minutes or per hour, depending on that you can calculate the frequency of that particular wave, that how many number of cycles these are going to run in that particular given time frame, that is going to be considered as a frequency. So frequency that will be going to be measured in the terms of hertz, denoted by Hz. This is the short form of denoting the unit of this frequency, which is equivalent to 1 cycle per second, or various multipliers of the hertz that can be also used in the terms of denoting the unit of frequency. So if you want to find out the relationship between this wavelength and the frequency, that will be given as C is equal to lambda into nu. Nu refers to the frequency, that is the cycles per hertz. Lambda refers to the wavelength, that will be denoted in the terms of meters, and C is nothing but the speed of light, which is nothing but the 3 into 10 raised to 8 meter per second. So these two parameters, these two inversely related parameters, these are very important. Understanding the characteristics of the electromagnetic radiations in the terms of their wavelengths and the frequency, this is considered as an crucial for the purpose of understanding the information which is useful for the extraction purpose, extracting the information from the remotely sensed data. Okay, so this is what all about the electromagnetic radiation. Now talking about the next parameter, we are supposed to understand the electromagnetic spectrum, based on which we can able to characterize the remote sensing application various fields or various aspects. So electromagnetic spectrum, that is going to be considered as a very important part, because based on which again we are supposed to place the sensors, or what kind of data that we need to collect, that is completely depending on this electromagnetic spectrum. So electromagnetic spectrum, that is going to range from the shorter wavelengths, which is going to include the gamma rays or the X-rays, to the longer wavelengths. These are going to include the microwaves or the radio waves. So there are several regions of the electromagnetic spectrums that are going to be considered as an useful thing for the remote sensing applications or the remote sensing data. So you are aware of this particular spectrum, so the various ranges of the wavelengths, and in which we can able to study this electromagnetic spectrum in detail. Like here you can see the gamma rays. This is the wavelength. This is going to range from 10 raised to minus 16 to 10 raised to minus 11. That is the wavelength we can able to see. This is going to be, it is in the direction of towards increasing side, and this is towards